Good morning, everyone. Today we are going to see about translation and rotational mechanical system. First, let us see mechanical translation system in detail. Here we are going to have three basic elements: mass, spring, and dashpot. So, what is mass? Is weight of mechanical system in the representation using M, and the spring representation is K. It is an elastic deformation of a body, and dashpot B. It is friction existing in the mechanical system. So here we apply Newton's second law of motion for translation system. So here the system is the sum of forces acting on body is zero. So with this we are going for list the symbols used here. We are having x, that is displacement of m, and v dx divided by dt, that is in velocity, and a is nothing but acceleration representation dv divided by dt, and mass m represents kg, and k represents thickness of spring, and b equal to viscous friction coefficient, and f is equal to applied force n, and fm equal to opposing force offered by mass of the body n, and fb opposing force offered by friction, and fk opposing force offered by elasticity. So now let us see the formulas for balance equation. First we take mass. So the mass representation is m. So whatever we are having, the basic symbol is taken as x, that is displacement, and f is applied force, and f is equal to applied force. So where we are going to apply, the opposite of mass is going to be calculated, that is taken as fm, that is opposing force due to mass, and the formula is Fm is equal to m caps m, that is d square x divided by dt square. So by Newton's second law, Fm is equal to m d square x divided by dt square. Now we are going for dashpot formula. Again, the applied force is going to be F, and the opposing force can be represented in Fb. So here we are having the formula Fd is equal to b dx divided by dt. So here also we apply Newton's second law, that is F is equal to Fb, which is equal to b dx divided by dt. Now we are going for spring formula. Now again the applied force is going to be F, and the opposing force is mentioned as Fk. So here Fk is equal to Kx. So according to mass, dashpot as well as spring, we have formula for this three. This is applied for all these differential equations. So now problem 1, here the problem is given as write the differential equation governing the mechanical system shown in figure, determine the transfer function. You can see a diagram. So here we have the three basic elements, that is M, K and B. So first we are going to draw the free body diagram, that by applying the system's input as well as the output. So before that we have to convert all this given system into f of s value. So the applied force is f of t, and the x is displacement, that is output. So first convert f of t is equal to L inverse of f of t, that is Laplace transform of f of t is equal to f of s. If it is x, we will take as x of s. So transfer function formula, that with respect to input x of s divided by f of s. So now free body diagram for node 1. So while seeing the problem, we can see what are the parameters are available there. So see, first we are going to draw the free body diagram for this M1. So what are the parameters connected here is K1 is connected, B is connected, K is connected, and B1 is connected, and X1 is displacement value. And here f of t is available with M2. Okay. So now we are going to draw this free body diagram. So first what we have to do is whatever the parameters in M1 that is given here, first we want to write for f M1, and what are the components or parameters connected with M1 is taken here. So by Newton's second law, sum of applied force is equal to sum of opposed force. So here we are going to sum all the parameters like Fm1 plus Fb1 plus Fb plus Fk1 plus Fk equal to 0. And now we apply the formula for respective parameter. For mass, it is m1 d square x1 divided by dt square. And for b1, that is b1 dx1 divided by dt. and this B is connected between the M1 and M2. So we have to take the displacement value as x1 minus x plus k1 x1, and the k is also connected between both the terminals M1 M1. So here it is k into x1 minus x. So now taking Laplace transform for this differential equation, let us take it convert into x of s values, and we have to take x1 as common and write all these values here. And now it is taken as x1 of s m1 s square plus b1 plus b of s plus k1 plus k equal to x of s into bs plus k. Now with respect to this equation, calculate x1 of s. So we can take x of s equal to bs plus k divided by, write the other values, bm1 s square plus b1 plus bs plus k1 plus k. So now free body diagram for M2. So how, what are the parameters connected in M2 is taken here, and it is sum, and the equations written with respect to the differential equation formula for M2, B2, B and Fk. And now taking Laplace transform with the zero initial condition. So we have to take all this value, then take common values. Now substituting x1 of s, already for m1 we have identified x1 of s value. So substitute that value here. So we can get replace one of all the x1 value, which is equal to f of s. Now take the values in common. X of s is taken as common, so we take cross multiply it and take proper LCM here. And now calculate the transfer function is x of s divided by f of s, and this is the final equation, that is m1 s square plus b1 plus b of s plus k1 plus k divided by m1 s square plus b1 plus b1 s k1 plus k into m2 s square plus b2 of bs plus k minus bs plus k square. Thank you.